It is now my honor to introduce Dr. Jerome Paros. Jerry is a distinguished 1960 graduate of UMass in physics and received an honorary doctorate in science at yesterday's commencement. A self-described measurement nut, he is an internationally recognized innovator and leader in the field of geophysical sensing systems. He and his wife, Linda, are also generous benefactors of UMass and the College of Engineering. This past year, they made the largest gift ever to the College of Engineering, $10 million. To establish the Paros Center for Atmospheric Research, PCAR, with a focus on developing innovative sensing systems and applications that will help protect communities and save lives. We are extraordinarily grateful for their generosity and vision. It is my distinct honor and privilege to welcome Jerry to the podium.
Good morning. It's a great pleasure to be with you today. First, congratulations to the graduates. I thank you and your family and friends for sharing the celebration with us. Secondly, congratulations to the College of Engineering for their 75th birthday. The theme of this talk is measuring up. There's a saying that knowledge comes from learning and wisdom comes from observation. So observational life experiences are key to the practical applications of knowledge. Observation involves making measurements. So measurements results are constantly being compared to the performance requirements. We're indeed celebrating the fact that you have measured up to the UMass requirements for graduation. Soon, measurements will be made of your job performance. Measurements have always played a huge part in my scientific life because good science comes from good observers making good experiments with good sensors. Now, the last few days, I've toured the campus like a time traveler because I entered UMass only 9 years after the College of Engineering was founded, and Massachusetts State College became the University of Massachusetts. So please accompany me as I expanded my UMass base of education to become a practicing scientist, entrepreneur, and philanthropist. In the 1950s, the number of students was a fraction of today's population. Tuition was a few $100s per semester. The library featured books on agriculture. The first student union building was built in 1957. And actually, the first satellite to orbit the Earth, Sputnik, went up in 1957, and that created the space race and generated a great deal of interest in science and engineering. So that was an exciting time. But today, you might look at the technology of the 1950s the way that I looked at the technology of the 1880s. So just imagine what your grandchildren will look at the technology of 2022. It'll be different. Anyway, I was always taking things apart to see how they worked, much as what I hope many of you do. And this was a combination of curiosity and necessity because things were constantly failing. They were always breaking apart. At that time, radios had vacuum tubes, automobiles had carburetors, there was no internet, mobile phones, computers, satellite navigation systems. a really different world. The engineering students had slide rules, and we spent huge amounts of time trying to gather relevant information to solve problems. On the plus side, compared to today, there was less need for filtering out bad information and a lot fewer distractions. So after graduate school and years of work in the aerospace sector, I was looking for ways to start up a technology-based business. So you might want, those of you who want to become multimillionaires and save humanity, listen. I realized that precision measurements are the fundamental basis of experimental science. And the commercial applications of experimental science, what you guys do in the laboratories, are the main drivers of technological progress. So to succeed in business, we needed to have some proprietary technical advantages. Now, we couldn't do it on good looks and charm alone, like you guys. Now, a technical interlude, okay? In the 1960s, the world of sensors was almost completely analog, and I thought that more precise measurements could be done in the time domain by many orders of magnitude. So we developed and patented some force-sensitive resonators whose frequency of vibration were a function of the applied load. So the principle of operation is like tuning a violin string. The more tension that you put on the string, the higher the frequency, and the change in frequency is a measure of the applied load. So we took this inherently digital device and improved it to develop quartz crystal load-sensitive resonators with unparalleled performance. So that was the proprietary technological advantage that we were looking for. So, for example, we designed transducers to measure different physical parameters. So if we took the resonator and attached it to a suspended inertial mass, we had the world's greatest accelerometer. If we attached the resonator to a bellows or a bourdon tube, we had the world's greatest pressure sensors. Applying it to a weighing platform, we had a scale, and so on. So with this proprietary technology and these potentially saleable units, we were ready to become entrepreneurs. So over 50 years ago, I founded Paros, and it still was an analog world, but we had a good vision of the future insofar as personal control computers and digital control systems were gaining traction. So our quartz-based companies focused on the creation of new products that could serve the scientific and industrial communities with improved inherently digital instrumentation. And it turns out that significant scientific measurements could be made for the first time that were impossible to make with the prior technology. So, thus the, incredible good fortune of the confluence of the quartz crystal technology and digital computers and control systems, microprocessor chips, and intelligent sensors came to be known as good planning. You get lucky, take credit for it. Very quickly, Paros grew into a multi-million-dollar business with applications in such areas, diverse areas of oceanography, meteorology, hydrology, energy exploration, process control, aerospace, and its laboratory instrumentation. Many of those areas which you'll be working in. And a number of brother-sister companies were formed and licensed for exclusive fields of use. This provided a diversified base for commercial applications as well as the opportunity to find appropriate partners through acquisitions and mergers. And of course, our financial performance was constantly being measured, okay? We don't get any passes on our performance being measured. And fortunately, our company and our brother-sister companies have already generated hundreds of millions of dollars in profits and cash distributions and taxes paid and exports, and the average return of investment for our shareholders exceeds 20,000%. So I expect no less from the companies that you are going to form. Now, decades ago, NOAA had developed some tsunami warning systems based on our pressure sensors. And in November of 2004, NOAA and I presented a paper recommending an expansion of their network of 6 tsunami warning buoys that were in the Pacific, and the governments that we were asking support from were not at all interested. 1 month later, the Indonesian tsunami caused 230,000 deaths and extensive property damage. So our phone was ringing off the hook a month later, but it was too late. Then Hurricane Katrina struck New Orleans with over 1,800 fatalities and $125 billion in property damage. So we tried to meet these public safety needs by developing new geophysical sensors that could predict, warn, and mitigate the effects of natural disasters. Our technical and business success was ready to be shared through philanthropic partnerships. In 2005, Vice Chancellor Mike Malone, former Dean of the College of Engineering, made a persuasive case for partnering with UMass in the atmospheric sciences. So we established funds in measurement sciences and environmental research. We then collaborated with your colleagues with the CASA group, who were doing radar research on extreme weather events. Obviously, it was successful because our most recent investment in UMass is a $10 million atmospheric research center gift to the College of Engineering. We look forward to our expanded partnership producing great results for science, education, and public safety. I congratulate all of you who have measured up and received your engineering degrees. Do great things and build a strong foundation for future generations. Go UMass.
Thank you, Dr. Paros.